Welcome to another Fast Math video, this time on circle segment theorems. Multiply intersecting chord segments in this way, such that A times B equals C times D. Here we see two chords intersecting in a circle, and we're interested in finding the missing chord X. It's actually very simple. All we need to do is multiply 6 times X, set it equal to 3 times 8. So 6x equals 24, and x equals 4. Let's check our work. Put a 4 in for x. 3 times 8 is 24. 6 times 4 is 24. 4 is correct. Let's look at a slightly more interesting example for this theorem. X minus 1 times x plus 3 will equal x times x plus 1. So we multiply these two polynomials together, x squared, and we have a plus 3x minus an x, so that means 3x minus x is plus 2x, minus 1 times 3 is negative 3, equals x squared plus x, distributing that x. These x squareds will cancel out, and we're left with 2x minus 3 equals x. So if we subtract this x to the other side and we add this 3 over here, you're going to get x equals 3, and we can check that. If we substitute in x and 3, this one would be 3. 3 plus 1 is 4. 3 minus 1 is 2. 3 plus 3 is 6, and it works. 3 times 4 equals 12, and 2 times 6 equals 12. So x equals 3 is correct. Our next theorem has two secant chords intersecting outside the circle, slightly more complex. The external segment times the entire segment length equals the external segment times the entire segment length. So it's A times A plus B equals C times C plus D. In this example, we have two secants intersecting outside the circle. So we have to remember that it's the outside segment times the entire length of the secant segment, equals this outside segment times that entire length. So we're going to have 4 times 4 plus 5, which is 9, equals x times x plus 9. So 36 equals x squared plus 9x. I'm going to subtract the 36 to the other side. And now I'm going to factor. We'll reverse distribute here, reverse FOIL. So I need two numbers that multiply to negative 36 but add to 9. I know they're going to be different signs because of the negative 36. So one's positive, one's negative. So it's two numbers multiply to 36 and subtract to 9. 12 times 3, that should work, right? So I believe the 12 goes here and the 3 goes here, and we can always check that. Our outsides minus 3x, our insides plus 12x. Minus 3x plus 12x is 9x, and 12 times negative 3 is 36. So I believe we factored correctly. This equation here becomes true when x is negative 12 or when x is 3. Now you have to examine both solutions. Now if x is negative 12, we're going to get a negative side length, which can't happen. So we're going to reject negative 12 because we can't have a negative side length. But if we have 3, well, that's fine. That should be fine, and we should test it. So if x is 3, 3 times the entire length, which is 12, that's 36. And then 4 times the entire length, that's also 36, so that works. So x equals 3, that's our solution. In this theorem, we have one secant segment and one tangent segment that meet at the same external point. Like the other theorem, the outer segment of the secant times the entire secant will equal the length of the tangent squared. So a times a plus b equals c squared. In this example, I have a secant and I have a tangent. And we're going to look at the theorem that states the outside piece times the entire length of the secant equals the tangent squared. So let's get to it. The outside bit of the secant times the entire length, you add those together, x plus 12, equals 8 squared, or 64, because that's the length of my tangent. Distribute. And then let's subtract the 64. So let's factor this guy. X and x gets me the x squared. So I need two numbers that multiply to negative 64, but add to 12. So I'm going to have one be positive and one will be negative. And so two numbers that multiply to 64 and subtract to 12, I believe that it's 16 and 4, because minus 4 times x is minus 4x, 16x minus 4x does give me 12x, and when I multiply those two, I get the negative 64. So that seems to be factored correctly. So this means that x is negative 16, or x could be 4. Now if I look at the negative 16 solution, that would give me a negative side length here, and that doesn't make any sense. But if x is 4, well, that's a perfectly fine one. So let's just test and make sure that 4 is the possibility, because we're going to reject the negative 16. And if 4 is here, let's see, that's 4 times the entire length. 4 plus 12 is 16. 4 times 16 is 64. And then you square the 8, and that's also 64. So that appears to check out. So 4 is our solution. There actually is another possibility where we can have two tangents that meet at an external point. So I guess we should mention that possibility. This is actually a much simpler case. The two tangents will be congruent to each other, so a much simpler sort of operation, and usually these aren't spoken about in the same context that we talk about the other theorems in this video. I hope this video was helpful. Thanks for listening and watching.